Quantum immortality is one of those ideas that sits at the border of science and philosophy, daring us to confront the fragility of existence while suggesting a loophole hidden within the deepest structure of reality. At first glance, it feels like a paradox wrapped in absurdity. How could one be immortal if every shred of evidence around us insists that life ends inescapably? Yet when filtered through the lens of quantum mechanics, the thought takes on an unsettling kind of plausibility. To approach it, one must begin not with grand conclusions, but with the peculiar behavior of the tiniest building blocks of the universe. On the macroscopic level, the world is predictable. If you push a marble across a table with the same force and angle 10 times, it will travel along the same path and land in the same place every single time. This regularity is the comfort of classical physics, a discipline born from Newton's principles that assured us the universe was a grand clockwork machine. But at the microscopic scale, predictability evaporates. Replace the marble with an electron and repeat the same experiment 10 times. Instead of identical results, the electron appears in different places, as if refusing to obey the determinism of the macroscopic world. It is not merely a matter of measurement error or experimental limitation. The randomness is woven into the very nature of the particle. Quantum mechanics was devised to tame this randomness, not by eliminating it, but by giving it structure. The electron is not a marble, not even a particle in the ordinary sense. It is a shapeshifter, a mathematical ghost described best as a wave. But unlike the waves we know in the ocean or in sound, this wave is not made of water or air. It is a wave of probability. It tells us where the electron is likely to be found, not where it actually is before observation. In a strange way, the electron exists everywhere its probability wave allows, until the act of measurement forces it to manifest in one specific location. Imagine firing an electron gun into your apartment. Out of 100 attempts, perhaps 80 times the electron lands in the living room wall, while 20 times it winds up in the kitchen. From this perspective, the electron is not truly in either room before being detected. It is distributed, smeared across possibilities, its essence captured by a wave function that assigns likelihoods to outcomes. The astonishing part is that this framework, bizarre and unintuitive, is breathtakingly accurate. It has been tested in countless experiments, and it works every single time, describing phenomena from semiconductor circuits that power your phone to the nuclear fusion in the heart of stars. And yet the success of quantum mechanics comes with a price. Unlike the comforting imagery of spheres orbiting spheres or fabric bending under the weight of mass, quantum mechanics gives no mental picture that corresponds to common sense. What does it mean to say an electron is 80% in the living room? Is the electron a ghost that is mostly here but partly there? Or is it something we cannot visualize at all? For over a century, scientists have argued about whether the wave function describes reality itself or simply our knowledge of possible outcomes. This is where quantum immortality sneaks into the conversation, for depending on how you interpret the wave function, the line between life and death becomes unexpectedly porous. Two dominant schools emerge from the debate. One group, often caricatured as the shut-up-and-calculate camp, treats quantum mechanics as nothing more than a mathematical grammar. For them, asking what the electron really is misses the point. The wave function is simply a tool to predict outcomes. Whether the electron is a marble, a cloud, or even something absurd like a fictional character is irrelevant. The mathematics delivers answers that match experiments, and that is enough. Reality, in this view, is unknowable beyond the probabilities we can compute. Opposing them are the interpreters, those who cannot accept a purely instrumentalist view. To them, the wave function is a real thing, a description of how reality itself operates. The most provocative among these interpreters advocate for the many worlds interpretation, in which all possible outcomes exist simultaneously in parallel branches of the universe. In this framework, if the electron has an 80% chance of being in the living room and a 20% chance of being in the kitchen, both outcomes occur, not merely as abstract probabilities, but as realities that unfold in different branches. The universe constantly splits, creating versions of events for every possibility. The implication is startling. If the electron splits into different versions across branches, and you are the one observing the electron, then you split too. There is a version of you that sees the electron land in the living room, and another that observes it appear in the kitchen. Both are equally real, equally valid, and equally present, though they can never interact. To you, the experience is singular. You are only aware of one branch. But the full quantum picture insists that every branch is populated, every branch carries a version of you, and every branch continues independently. It is within this framework that quantum immortality emerges. Consider a thought experiment. Two detectors are connected to a nuclear bomb placed in your living room. If the electron detector in the living room registers a hit, the bomb detonates instantly. If the detector in the kitchen registers the electron, the bomb remains silent. Every time the electron gun fires, your life hangs on the distribution of probabilities. With an 80% chance of annihilation, you should not survive more than a few attempts. In a universe with only one reality, your story ends quickly, reduced to vapor in your own living room. But if the many worlds interpretation holds true, something stranger unfolds. Each time the electron is fired, reality splits. In some branches, you die instantly. In another, you survive. From your subjective perspective, however, you can only inhabit branches where you survive. You cannot experience the versions of yourself that are obliterated, because there is no consciousness left to register those outcomes. Therefore, no matter how many times the experiment is repeated, there is always one surviving version of you, and it is always the version you experience. At first, it might feel like luck. One survival could be brushed aside as chance. A dozen in a row might still be explained away. But after surviving hundreds of rounds, the odds in a single universe framework collapse into absurd improbability. A 1 in 10 duovigintillion chance, a 1 followed by 70 zeros. At that point, surviving is no longer luck. It is evidence that the universe is branching, and that you are the beneficiary of quantum immortality. The thought experiment of the bomb, as morbid as it is, highlights the unsettling consequences of taking the many worlds interpretation seriously. Every act of measurement becomes a branching point, not just for particles, but for entire observers. Each moment of observation is a fork in the universal road, and every possible outcome exists along one of its branches. Quantum immortality is not a magical shield that prevents you from dying. It is the logical extension of inhabiting only those branches where your consciousness continues. The deaths still occur brutally and in staggering numbers, but they are sealed away in other worlds that you, by definition, cannot perceive. The difference between this and conventional immortality is crucial. In traditional conceptions of eternal life, the body endures, or the soul persists in some unified sense across time. Quantum immortality, on the other hand, is narrow and subjective. It does not preserve all versions of you. It preserves only the chain of versions that continue to have conscious experience. This creates a strange hierarchy of realities. From the outside, looking at the entire tree of branching worlds, the majority of versions of you perish in tragic accidents. Yet from the inside, from the perspective of the conscious thread, you continue indefinitely. The odds become irrelevant because you only ever find yourself inside the branches where survival occurs. This is why the concept feels simultaneously exhilarating and horrifying. It suggests that, no matter how unlikely, there will always be a path in which you survive. A tumor begins to grow, but in one branch a cosmic ray destroys the first malignant cell before it divides. A lightning bolt heads directly toward you, but in another branch quantum fluctuations alter its path just enough to spare you. A massive object falls from the sky, yet in one improbable but real branch, the atoms of the object quantum tunnel through your body without interacting. Against every conceivable danger, there exists at least one sequence of events in which you persist. Your thread of consciousness is, in this sense, unbreakable. But there is an important ethical and existential caveat. The survival of one version does not erase the suffering or death of countless others. In the branching structure of the multiverse, most of your versions end in tragedy. The immortality you experience is private, solipsistic. You feel like you cannot die, but at every branching, an overwhelming number of you do. If you value yourself as a singular being, this survival might seem comforting. If you value yourself as the sum of all your potential versions, then quantum immortality is a nightmare of endless death. This paradox reveals a tension at the heart of the theory. On one hand, quantum immortality provides a comforting thought. The stream of consciousness you inhabit is never severed. On the other hand, it forces you to accept that every dangerous choice spawns vast numbers of universes in which you do not make it. Thus, even if one version survives skydiving without a parachute, it would be morally absurd to jump without one, because for nearly every other branch, your story ends in silence. Caring only about the version of you that survives is a kind of selfishness against yourself. And then comes the uncomfortable question: is this idea even scientific? The shut up and calculate camp rejects it outright. If alternate branches cannot be detected, measured, or influenced in any way, then they do not qualify as part of science. To them, the many worlds interpretation is a philosophical indulgence, a story layered onto the mathematics, not an extension of it. If quantum mechanics is only a predictive grammar, then speculating about branches is no more scientific than imagining fairy tales. The probabilities describe experiments, nothing more. When the detector clicks, the electron is where it is, and the bomb either explodes or does not. Talking about alternate U's that perish elsewhere is meaningless because those worlds, by definition, cannot be checked. Yet the elegance of the many worlds interpretation has an allure that pure pragmatism cannot smother. It resolves the strange discontinuity of wave function collapse. Instead of asking why a probability suddenly becomes a definite outcome at the moment of observation, many worlds asserts that it never collapses at all. Every outcome continues, each in its own isolated branch. The mathematics does not change, the predictions remain the same, but the story becomes coherent. No randomness, no collapse, just endless branching. To many physicists, this makes it beautiful, even if it is unverifiable. Quantum immortality grows naturally out of this elegance. If you accept that every possible outcome exists, then it follows inevitably that there is always a version of you that survives. But this survival is not triumph. It is not invulnerability. It is a strange, lonely inevitability that extends only along the single thread of your experience. When the improbable survival becomes astronomically unlikely, surviving it is no longer good fortune. It is the logical proof that you are in one of the branches where survival occurs. And since you cannot experience the others, your awareness is trapped in a bubble of continual existence, even as your other versions perish uncountably. This leads to a haunting picture of life under quantum immortality. You will always find yourself surviving, but you will also always be increasingly isolated. Each disaster that should have killed you, each fluke that spares you against all odds, eliminates countless other versions. The longer your survival stretches, the more improbable your existence becomes in the broader multiverse. From your perspective, however, improbability means nothing. You keep waking up, keep breathing, keep experiencing the flow of time, as if the universe conspires to keep you alive. But in truth, you are merely walking the narrow path carved by chance, a path surrounded on all sides by the silent graves of your other selves. At this point, the idea bends toward the philosophical and even the spiritual. Does it matter that other versions of you died, if you cannot perceive them? Or is their existence as real as your own, demanding that you care about them? If your consciousness is guaranteed to persist, does it grant you license to act recklessly, knowing you will always continue somewhere? Or should the reality of innumerable deaths instill caution, compelling you to safeguard as many versions as possible by making careful choices? The many worlds interpretation does not answer these questions. It only frames them. The mathematics remains indifferent, blind to meaning. But once translated into human terms, the theory forces us to grapple with what survival actually means. Are you immortal if your awareness never ceases, even though almost every other version of you dies? Or are you mortal because, in the grand totality of all branches, death vastly outweighs survival? The answer depends on perspective, and perspective itself is the one thing that quantum mechanics seems to fracture infinitely. The cosmic implications of quantum immortality ripple far beyond the confines of a living room bomb experiment. If every possible quantum event unfolds in its own branch of reality, then the very fabric of existence is a vast, ever-expanding tree of possibilities. Each fork on the branches marks not only the fate of particles, but the fate of observers, planets, galaxies, and civilizations. The simple act of measuring an electron becomes a microcosm of a universal process, the continual blossoming of worlds. Within this framework, immortality is not a privilege granted by divine decree, nor a miracle wrought by technology. It is the unavoidable consequence of being a conscious observer entangled in the branching structure of quantum mechanics. Consider what this means on the scale of a human life. From the moment of birth, existence is a gauntlet of probabilities. Illnesses threaten, accidents lurk, and natural disasters strike without warning. Statistically, there are innumerable points where a person's life could be cut short. Yet, in the quantum view, every one of these threats is met with a branching. In some universes, the child dies young. In others, they live into adulthood. In still others, they survive well into old age. The persistence of consciousness ensures that in at least one sequence of events, they continue to live. Thus, no matter how many dangers exist, no matter how small the odds, there is always a thread of survival. This is what creates the impression of quantum immortality, the unbroken continuity of awareness along improbable paths. The seductive part of this idea is that it makes death seem like an illusion. From the subjective perspective, you never experience your own end. Even if you are in a car accident, there will always be one branch where you survive the impact, another where you are rescued in time, and perhaps one where you walk away unscathed. The versions of you that perish dissolve into silence, but your awareness cannot inhabit their void. Instead, it slides effortlessly into the surviving versions. In this way, you are always the one who lives on, never the one who dies. But immortality in this form is not peace, nor is it bliss. It is survival stripped of guarantees about quality. As time passes, the branching structure of the multiverse filters out the easy paths, leaving only increasingly improbable continuations. Imagine living long past the age where your body should have failed, surviving strokes, heart attacks, and cancers by sheer quantum flukes. One by one, the natural probabilities of failure are exhausted. Yet in some universe, you continue. The end result is a survivor who drifts further into improbability, aging into extreme decrepitude, persisting not because biology allows it, but because there is always some branch where the improbable happens. This is the darker side of quantum immortality, the possibility that one's consciousness becomes trapped in a corridor of ever-worsening survival, where death recedes like a mirage but never arrives. Philosophers have speculated on this unsettling possibility. If consciousness is tied to survival, then quantum immortality implies that you might eventually find yourself existing in states that are functionally unbearable, kept alive only by the rarest quirks of probability. Rather than eternal youth or timeless serenity, you could be condemned to experience a form of endless decay, surviving diseases and accidents that should have ended you, enduring pain and deterioration that no natural body was meant to sustain. The comforting idea of immortality becomes, in this light, a nightmare of persistence. You cannot die, but you cannot truly live either. And yet, from another angle, this same framework offers a kind of hope. If there are always branches where you survive, then there are also branches where you thrive. The same improbable flukes that prevent your death could, in theory, grant you extraordinary fortune. A fatal illness might vanish as mysteriously as it appeared. A freak accident might transform into an unlikely miracle. Just as improbable survival can lead to endless suffering, it can also lead to remarkable recoveries and inexplicable strokes of good luck. Quantum immortality is not inherently a curse. It is a spectrum of improbable paths, some bleak, some wondrous. The question then becomes, which paths are more likely to dominate the continuity of consciousness? Is awareness naturally biased toward survival of any kind, regardless of quality? Or is there some hidden tendency toward meaningful existence? The mathematics of many worlds provides no answer. It cares nothing for comfort or despair. It merely declares that every possibility exists, and that one thread of consciousness will always persist. Interpreting this, however, forces us to confront our own values. Do we prefer existence at any cost, even in misery? Or do we find meaning only in certain forms of life, rejecting the idea that bare survival is sufficient? Another implication of quantum immortality is its challenge to the concept of risk. Ordinarily, risk assessment is based on probability. The higher the chance of harm, the more cautious we should be. But if there is always a branch where you survive, then from your own perspective, you cannot lose. The coin always lands on the side that keeps you alive, no matter how unlikely. This line of reasoning could tempt someone into reckless behavior, wingsuit flying without training, confronting danger without fear, treating life as a playground where consequences are illusions. After all, you will always find yourself surviving. But this reasoning collapses under ethical scrutiny. Each reckless choice does not erase the deaths of other versions. It multiplies them. The multiverse fills with corpses that are you, versions whose lives end abruptly and painfully. Even if you continue, their existence is just as real. To act recklessly is to slaughter countless versions of yourself for the sake of one survivor. In this sense, quantum immortality does not free you from responsibility. It heightens it. Every choice you make ripples through the branches, and the more careful you are, the more versions of you live on. This realization reframes ordinary caution in life. It is not just about preserving the single version of you that you currently inhabit. It is about maximizing the number of surviving versions across the multiverse. When you step out of the way of a falling object, you are not just saving yourself here. You are enriching the multiverse with countless other continuations of your life. Your choices become acts of preservation on a cosmic scale, increasing the density of your existence across the branches. In this way, morality acquires a new dimension under quantum immortality. To act responsibly is not merely to protect the present, but to amplify survival across all possible worlds. There is also the question of identity. If you exist in countless versions, which one is truly you? Is your identity confined to the conscious thread you experience, or does it extend across all versions simultaneously? Quantum immortality tends to privilege the thread, since it insists that you will always find yourself surviving. But if all versions are equally real, then you are not just the one who survives. You are also the one who dies over and over in countless branches. The comfort of immortality is undermined by the recognition that you are both eternal and mortal, depending on where you look. Ultimately, quantum immortality transforms death from an absolute endpoint into a shifting horizon. It cannot be reached from within, because the moment of death cannot be consciously experienced. Instead, consciousness always slides into the surviving branches, but death still occurs everywhere else, in overwhelming abundance. To call oneself immortal under these conditions is to misunderstand the cost. You are immortal in experience, but mortal in reality. You survive forever, but you die endlessly. The paradox cannot be resolved. It can only be endured. The ultimate weight of quantum immortality rests not in its scientific equations, but in the philosophical burden it places upon us. Physics can describe branching universes, probability waves, and mathematical symmetries, but it cannot tell us what it feels like to live inside them. Consciousness, stubbornly subjective, is the lens through which these abstract ideas acquire meaning. And when consciousness collides with the logic of many worlds, the result is a picture of existence that is both liberating and terrifying. To live under quantum immortality is to accept that you will never encounter your own absence. The finality we associate with death becomes unreachable, always deferred to another branch, always avoided by some improbable turn of events. This alone reframes the human condition. Throughout history, mortality has been the shadow against which all philosophy, religion, and art have defined themselves. We strive for legacies because we know we will die. We cling to fates that promise continuations beyond the grave because we fear extinction. Yet if quantum immortality is correct, then extinction does not exist from the inside. You are always there, continuing. The fear of nothingness is misplaced, because nothingness can never be experienced. But this replacement of extinction with endless survival does not provide the comfort it seems to promise. Immortality in this sense is not a gift, it is an inevitability, and inevitabilities carry consequences. Consider the psychological strain of existing beyond the boundaries of probability. As each decade passes, the improbability of your survival compounds. Perhaps you survive illnesses that kill nearly everyone in parallel branches. Perhaps you endure disasters that leave no one else standing. You begin to occupy a timeline where everything conspires to keep you alive, yet at the cost of growing isolation. Each event that should have ended you creates an ever-widening gulf between your improbable survival and the normal trajectory of life. The question becomes, can meaning survive under such conditions? Mortality gives life urgency. We cherish moments precisely because they are finite. Remove finitude, and what becomes of value? If you cannot die, then the stakes of existence collapse. And yet, paradoxically, the lives of your other versions remain finite, meaningful, and irreplaceable. Their deaths, multiplied across branches, remind you that even if you continue, most of you does not. Thus, meaning shifts from the survival of the self to the preservation of as many versions as possible. Quantum immortality, far from granting license to recklessness, demands a moral seriousness that transcends individual experience. This perspective reshapes responsibility. Every choice is a fork that spawns realities. To walk recklessly into danger is to create a forest of branches where your life ends, leaving only a single improbable twig where you continue. To act with care is to thicken the branches of survival, weaving a multiverse dense with continuations of yourself. In this sense, responsibility extends beyond the here and now. It stretches across the cosmic architecture of possibility. Each decision is a negotiation with infinity, and each act of caution preserves not just this life, but countless others that you will never consciously inhabit yet still embody. Here lies the irony. The very theory that tempts us to believe in invulnerability is the same theory that imposes greater responsibility than ever before. The gambler's logic of "I will always survive" is exposed as a kind of moral blindness, ignoring the vast cemetery of versions sacrificed for one improbable survivor. True wisdom under quantum immortality is not to exploit the loophole of subjective persistence, but to honor the totality of yourself across all branches by maximizing survival everywhere possible. Immortality, then, is not a personal escape from death, but a mandate to treat every version of your life as sacred. Of course, all of this rests on interpretation. The shut up and calculate camp reminds us that science has not proven the existence of alternate branches. The mathematics of quantum mechanics requires no ontological commitment to many worlds. Probability waves function perfectly as predictive tools without invoking an infinite tree of universes. From this perspective, quantum immortality may be nothing more than a philosophical mirage, a byproduct of stretching and interpretation beyond what can be tested. If there is only one universe, only one unfolding of events, then immortality collapses into the same mortality that has haunted humans for millennia. A falling machine does not tunnel harmlessly through your body. It crushes you, and there are no alternate branches to absorb the loss. Yet even if the many worlds interpretation is never proven, the thought experiment itself holds value. It forces us to examine our assumptions about life, death, and identity. It pushes us to ask what it means to survive, and whether survival alone is enough. It makes us confront the difference between subjective experience and objective reality, between what consciousness perceives and what the universe may actually contain. In doing so, it brings physics into dialogue with philosophy, uniting the rigor of equations with the vulnerability of human meaning. Quantum immortality also underscores the limits of scientific knowledge. Physics may map probabilities, but it cannot dictate how we ought to live in light of them. That task remains ours. If we embrace the possibility of endless survival, we must decide whether to live recklessly or responsibly, selfishly or ethically. If we reject it, we must still face mortality, but perhaps with renewed appreciation for the uniqueness of a single life. Either way, the confrontation enriches us. By staring into the abyss of possibility, we gain a sharper awareness of the present. In the end, quantum immortality is less about living forever than about recognizing the profound entanglement between possibility and responsibility. Whether or not many worlds is true, the idea that every decision splinters reality reminds us that our choices matter, not just for ourselves, but for all the versions of us that might exist. To live as though only one version matters is to ignore the richness of existence. To live with awareness of the branching is to honor the infinite web of potential woven by every moment. Perhaps this is the true lesson hidden in the theory. Immortality is not about defying death, but about expanding life. Each action that preserves, protects, or nurtures contributes to the abundance of worlds in which you endure. Each reckless act diminishes that abundance, leaving behind a thinning thread of improbable survival. Life, then, is not measured only by duration, but by the density of possibilities it sustains. The many worlds tree continues to branch, whether or not we choose to believe in it. The wave functions ripple outward, probabilities crystallizing into realities that overlap invisibly with one another. Somewhere, a version of you is spared disaster. Somewhere else, another is not. The only certainty is that the thread of your own awareness continues, winding its way through the labyrinth of possibilities. What you do with that awareness, whether you treat it as a license to gamble or a responsibility to protect, determines not whether you live forever, but how meaningful that forever becomes.